complex rational expressions. All we're going to do is simplify. There's two techniques. I'll show you one, maybe two today. But one technique I want to show you that's continuous to what we've been doing. Right? So I think this technique will be the easiest for you guys. So we're going to start off with two fractions, or a numerator, 3 plus 9 over x, over another denominator of x minus 7 minus 30 over x. All right, so there's fractions and fractions, hence it's named complex fractions. I'm not going to do anything different besides just tackle these one at a time. And this is what I mean. My first fraction, 3 plus 9 over x. I'm going to look for a common denominator here. So I'm going to look for an LCD here. And then I have another fraction of x minus 7 minus 30 over x. I'm going to look for an LCD here as well. This is technically 3 over 1. So I have a denominator of 1 and a denominator of x. My common denominator between the two of them is just x. Right? That's probably one of the easier ones. The next fraction, I have x over 1, 7 over 1, and 30 over x. Again, two of my fractions have a denominator of 1. The third has a denominator of x. So the denominator there is just x. All right, first one. So I have 3 over 1 plus 9 over x. This first fraction is missing a denominator of x, so I'm going to multiply both numerator and denominator by x. And that's going to leave me with 3x plus 9 over x. The second one is x minus, or x over 1 minus 7 over 1 minus 30 over x. First fraction is missing an x, so I'm going to multiply both numerator and denominator by x. Second fraction, 7 over 1, is also missing an x, so I'm going to multiply both again, numerator and denominator by x. And when I simplify all this, I get x times x, which is x squared, minus 7x, minus 30, all over x. So I simplified this top numerator, I simplified the denominator, and then I'm going to just rewrite this one more time. I'll do this a few times just to show you what it is, and then I'll stop doing this at some point, okay? So I got 3x plus 9 over x was my whole denominator here. And that was all divided by, or all over, the second fraction, which was x squared minus 7x minus 30 over x. And this just goes back to just simplifying, right? This symbol here is a fraction. All that means is just division. So if I rewrite these separately, I have 3x plus 9 over x. That just means to divide. And x squared minus 7x minus 30 over x. And now we're just back to dividing fractions here. I'm going to keep change flip. So 3x plus 9 over x. Multiply, so times x over x squared minus 7x minus 30. Now that brings me right back to just simplifying the fractions. Factor what you can, so 3x plus 9 factors into, factor out of 3, and I get x plus 3 over x times x over. So 3 times the quantity of x plus 3 over x, keep change flip, and then I'm going to factor this x squared minus 7x minus 30. What if factors of negative 30 to add up to negative 7? Right, so this is going to be x and x. 10 times 3 is 30, negative 10, and positive 3 gives me my negative 7. From here, I'm going to establish my domain. So I got x cannot equal 0, and that simplifies out, so therefore there's a hole there. Then I have x plus 3, which means that x cannot equal negative 3, but that simplifies, so there's another hole there on the graph, and that just leaves me with another denominator of x minus 10, so x cannot equal 10. That does not simplify out. That becomes a vertical asymptote, and that all simplifies to 3 over x minus 10. I'm going to tackle this again with finding the LCDs of each one. LCD of the first one, I have 2 over 1 x and x squared. Right? I can't take away from x squared. I can only just build on it. denominator, 2 over x squared minus 1 over x cubed. I can't take away from x cubed, I can just build the x squared to get to the x cubed. So this one's going to be x cubed. Okay. So my first fraction, 2 over 1, and I'll write these out right for now. 2 over 1 plus 3 over x minus 2 over x squared. And put the missing pieces that they have. So the first denominator is missing x squared, so I'm going to multiply this numerator and denominator by x squared. Second fraction, 3 over x is missing just an x, so I'm going to multiply this one by x. And the third fraction is not missing anything, so that's just going to stay as minus 2. So when I rewrite this, I'm going to be left with 2x squared plus 3x minus 2 over x. First one simplified. Right? Numerator simplified. Denominator, 2 over x squared. So I'm going to rewrite this, 2 over x squared minus 1 over x cubed. So my first fraction is missing an x to get x cubed. So multiply the numerator and denominator both by x. Second fraction already has the x cubed, so no big deal there. So you got 2x minus 1 all over x cubed. I'll write this out a few more times and then I'll shortcut this in the next couple steps. So I have that first 2x squared plus 3x minus 2 all over x squared. My first numerator simplified, all over my denominator simplified, which is 2x minus 1 over x cubed. You can skip this step as soon as you feel comfortable with this. And again, all that means is you take your first, you take the numerator, and you divide it by your denominator. Division implies multiplication when you do a cube change flip. So 2x squared plus 3x minus 1 all over x squared times x cubed over 2x minus 1. I'm going to start simplifying here before I start dealing with what's a whole and what's a vertical asymptote. 2x squared plus 3x minus 1 simplifies to 2x and x. This is going to be 2 and 1, positive 2, negative 1. However you want to factor that. X squared times x cubed over 2x minus 1. Domain. X squared in my denominator, so x cannot equal 0. It does simplify with the numerator, leaving me with just x in the first numerator, so it does simplify all completely, so there's a hole there. Second denominator there, x cannot equal 1/2. That one simplifies as well, creating another hole in the graph. What's left? X times x plus 2. This one's a little nicer for us. The numerator 5 over x plus 4 is already simplified. I can't simplify this anymore. Right? So 5 over x plus 4, I don't need to find any LCD here. All done for me. The denominator is missing. It's not completely simplified. The denominator here has a quantity of x plus 4 and has a factor of x plus 4 and has a factor of x. So the LCD of this one is going to be x times x plus 4. Just be careful because you can't just add 4 to this one and add 4 to that. That's not how it works, right? You got to do it by multiplication. So when I rewrite this, my first fraction here, this one's missing an x. I'm going to shortcut this a little bit here. So this one needs to be multiplied by x. So this numerator needs to be multiplied by x. This denominator needs to be multiplied by x plus 4. So this numerator also needs to be multiplied by x plus 4. So when I have my first numerator is fine. Simplify all this, I got x times 1, which is x, plus 2 times the quantity of x plus 4, all over my common denominator of x times x plus 4. Simplify as much as you can before you do cube change flip. This will give me here, x plus distribute to 2, 2x Distribute 2 again, plus 8 over x times x plus 4. Combine like terms, 1x and 2x is 3x plus 8 over x times x plus 4. Now my numerator is completely simplified, 5 over x plus 4. My denominator, which has this addition here, that's all completely simplified into one fraction. So I'm going to keep change flip. So I got 5 over x plus 4 divided by all this, or times, keep change flip, x times x plus 4 over 3x plus 8. Once you're here, establish your domain. So I got one domain, x plus 4, so x cannot equal negative 4. There's an x plus 4 in my numerator, there's a factor of x plus 4 in my denominator. Simplify those out, creates a hole in the graph. There's another denominator of 3x plus 8, which means that x cannot equal negative 8 thirds. Nothing simplifies with that, creating a vertical asymptote. What's left? 5 times x, 5x, over 3x plus 8.